How's everybody doing? Good. Day two of 8 weeks. Today we're going to talk about pandas. If you didn't already get some Smarties, feel free to grab some. Maybe I can have this be passed around. If you didn't already get some, feel free to take some. Would you mind just passing that to the right, and then we'll take it all the way around. Okay. Zoom is recording, so we are in business. Let's get started with pandas, which we already started last time. So to orient you again to this data science life cycle. So last time we talked briefly about this life cycle of data science where we can enter in two different places. Where are we today? Today we are in the bottom right. We are in the bottom right, exploratory data analysis. So this week, normally this would say week one and week two, but just this week, then during the summer, we're going to be talking about tabular data, data science, and pandas. Okay, we're not using that data science package anymore from Data 8. We're now talking about pandas. And then next week, both Michael and I will be lecturing. We're going to be talking about exploratory data analysis, actually working with some data sets, how to clean your data, and then one of my favorite topics, but colloquially not, of students, regular expressions. But I'm going to try to convince you that regular expressions are more interesting than you might think. Okay. So today, I had a friend in graduate school sometimes describe certain classes or certain lectures as like a broccoli and carrots lecture. And every class has some of those, and broccoli and carrots lectures are like really important, but they can sometimes come off a little dry, but they enable you to do a lot of really important things. So depending on your preferences, today may be a broccoli and carrots lecture for you or not. Just keep in mind, this is going to be a 3-lecture series on the basics of pandas. The pandas documentation is vast. If there's something you want to do with a table, there's probably a specific pandas function for it that I'm not even aware of, okay? And there's probably even things in this lecture that if you ask me on the fly, I'd probably have to look up the syntax. That's another big piece of today. I'm going to show you lots and lots and lots of different syntax, but that doesn't mean I'm expecting you to memorize all of those pieces of syntax, and that would not be a very productive use of your time. The goal today is really just to see how much can be done with pandas and how you can do the same thing in lots of different ways with pandas. Understanding the code I'm showing you today is a lot more important than memorizing every little bit of syntax. We'll see in a bit that Data 100 has a reference sheet that you can use on the exam, and I think it's sort of criminally underused. As you study for the exam, of course, you're going to memorize more and more of these functions, but it's okay to look back at that reference sheet. That's how a data scientist works in practice. So just keep that in mind because you will be seeing lots of syntax today. So let's dive right in. Pandas is sort of the industry standard tool for working with tabular data. This is what people use in industry and academia, in addition to other programming languages like R. You can do all kinds of things with Panda. We're going to see all of those in the next 3 lectures. And this first week of Data 100, like I said, is sort of a boot camp in pandas because we're going to be using pandas throughout the course on your homework assignments, and then on the exams, there's always big pandas questions, so just keep that in mind. And like it says at the very bottom here, much of the work is going to be in translating syntax from Data 8. You've learned a lot of the table manipulation operations that we're going to be talking about, just in a different language. And so now we're just moving you up to pandas, which is more industry standard. Okay, so today is going to have a demo that's associated. You'll notice that I will be going back and forth to a coding demo quite a bit today. Okay, the demos are located on the website. So when we have a demo, I highly recommend you work along on your own laptop. If you go to the website, just the regular course website, ds100.org/su25 for summer 25, you go down to lecture 2, you click on lecture 2, it'll open a page with all kinds of lecture 2 materials. Once the recording is up, the recording will also be there. But one of the items on there is the code, the actual notebook for the lecture. And most lectures will have an associated demo that we may or may not work through together in class. But just keep in mind, that's sort of the notebook I'm going to be working with today. There's some other useful information there. We're not going to be going through this Data 8 translation guide, but if you're really familiar with Data 8 notation and you want something to help you translate between pandas and table syntax, you can take a look at that notebook. And the data we're going to use today is in the data folder. Okay, so DataFrame series and indices. We started with series last time, and we mentioned what DataFrames are. So we're actually going to jump right into a demo because we already started learning about series last time. So I'm going to scroll on over to the demo now. and we'll talk through some of the elements of the demo. I'm going to work not super fast through the demos, but somewhat quickly. It's worth going through these on your own as well. I won't read every single bit of text. There's lots of nice explanatory text in a lot of these demos, so I highly recommend going through them. But let's go ahead and go through here. So at the very top level in Data Hub, we got to import pandas. Import the pandas package, and we're importing it as PD. That's the alias for pandas. We saw this last time. And so this is exactly the same thing we saw in the slides before. If we want to construct a series, a lot like a NumPy array, these are the columns of a data frame. We can use the pd.series function, and we're passing in a Python list, welcome to data 100, and just printing out that list. So if I run this, I get that exact same series we saw in the last lecture. We also saw in the last lecture, we can extract the values of that series and also the indices of that series. S.values will give me back an array of all those string values that we just passed in, and s.index gives me this fancy range index object that you don't have to worry about in data 100, but clearly is saying something between 0 and 2. Okay? A couple other things that we learned before we get into a Slido. We can construct a series with a custom index. So instead of just passing in values, we can actually pass in a custom index. So notice instead of 0, 1, 2 here, which is the default, we now have ABC. Okay, so we'll see this is useful throughout the course. Once again, you can extract the values and index and see that those have been changed. And then you can also reassign the index. So if we do s.index and we pass in a new set of values, it'll overwrite that original index. And a lot of this will make more sense in context on the homework. We're sort of just giving you the nuts and bolts here in the lecture. Okay, selection in series. So we saw this as well. So again, this is review. Now we're just actually playing with the code. This was how do you select elements out of a series? How do I pick one value? How do I pick multiple values? We saw a couple of these last time. So I'm going to construct a series here that we're going to use for this problem. This is the same as the series we saw at the very end of the last lecture. So let's say I want to pluck out one of those values. I want to pick out this 4 that's indexed at A. How do I pick out that 4? I index into my series S, passing in the string A, single or double quotes are fine. Okay, same idea. If I want to pull out more than one value, I pass in a list. I pass in a list. Common typo, don't include the inner brackets. Got to make sure to include those because we're passing in a list to the indexer. And then again, we saw last time this Boolean condition. If I compare my series S to something, so greater than 0, I get a Boolean series back. And then I can use that Boolean series, which we call a Boolean mask, to only pick out the elements of the original series that are true. So that picks out the first and the very last element of that original series. Okay, so that's just a review from last time, actually just running some of the code that we see in the slides. So let's head back to the slides here, and I believe we have a Slido. So let's give this one a go. Slido should work well today. We did lots of testing, so we should be in business, but go ahead, give this Slido a go. And if you have questions, feel free to raise your hand. I can come around and help. You can also ask on Slido, and we have people answering questions on Slido. Our enrollment is 150, but not everyone is in synchronous lecture. So we got to find the number that we tend to settle on, and then we can keep going here. So let's actually go try this out. So I think this Slido will stay live if you're already on it and still thinking through while I move over to the demo. So if you scroll to the very bottom of the demo, we actually have the Slidos there. If you want to mess around with some of the code, I recommend trying it out on your own before you mess around with the code to get the right answer. Again, all the Slidos are just graded on completion, not correctness, okay? So if we go to the bottom, okay, here was the question that we just did. We constructed a series with the numbers 4, 5, 6 and an index of 1, 2, 3. Okay, I just said series and my phone thought I was saying Siri. So let me put in this example and let's go take a look at it. So this is the example from the Slido. What do we get back? Something we've seen pretty similarly before. We have index 1, 2, 3, and we have values 4, 5, 6. So if I were to go print out what are the values of this series, I'm going to get those numbers 4, 5, 6 back. And so then we're doing something a little different here. So in the Slido, we're taking our original series, we're filtering to wherever we're greater than 4. So notice 5 and 6 are both greater than 4, whereas 4 is not greater than 4. So we now have this Boolean mask. Okay, so we're masking our original series to only include the last 2 elements. And if we grab the 2 values from that series, we're going to get 5 and 6. We're going to get 5 and 6. So let's see, did the Slido stay open while we did all that, or did people get kicked out? Still open? It looks like we have a couple more people, so that's good. Okay, great. All right, looks like we're getting it. Looks like we're getting it. Very good, everybody. Okay, we're going to do lots of Slidos like this today, so you can practice a lot of the things we talk about. And like I said, they're all at the bottom of that demo notebook, so you can take a look. Okay, so data frames in Data 100 and elsewhere consist of series. Each of these series is kind of like a column of that data frame. So what is a data frame? It's a collection of series that all share the same index, so that the first element in each one of those series means the same thing, the second element corresponds to the same row, and so on. So like we saw before, we can put together series that all share the same index to get a new data frame. Okay, so the data frame elections that we saw before that we're going to play with throughout the Pandas lectures consists of a series year, candidate, and a couple other series. So let's now dig into the actual mechanics of creating a data frame. So the general syntax of creating a Pandas data frame looks like this. You usually write pd.dataframe, and then you pass in some information. And there's lots of ways to create a data frame in Pandas. The first thing doesn't actually even use this general syntax. The first thing doesn't even use this syntax from a CSV, which I'll show you in a minute. But like I mentioned before, again, understanding the syntax is more important than memorizing all of it today. Just make sure you understand what's going on. Data scientists look up syntax all the time. Again, knowing what you want is a lot more important than precisely how to code it. Generally, how to code it's probably good. So the first way, and very common way, to generate a data frame is to actually import it from a comma-separated values file. You actually just import the data frame pd.read_CSV. In lots of language, there's read CSV with no space. It's read.csv. Believe me, I've had to look up, is it a dot or an underscore or no space many times in Pandas. Things as simple as that. Sometimes you even have to look up on the fly. That is totally fine. So that's one way to get a data frame. Read it in from a CSV. And of course, there can be issues on read, but that's the general idea. Other ways to make a data frame, and what you would use sort of depends on context. A little bit trickier here. So another way we can do it is pass in a list of values and name our columns. Notice this looks a lot like what we did for series, except instead of an index, we gave column names. Rather, we didn't pass in an index here. We gave it a name, numbers, and we still passed in those same values. So this one column data frame looks a lot like a series. Something to keep in mind, those are two different things. One column data frame versus a series. Okay, you can convert between them pretty easily. We'll see that in a bit. Another way to construct a data frame is passing in these list of sublists. So notice we have an outer list here, and we're passing in inner lists. Each one of those inner lists represents a particular observation. So you might imagine you have data streaming in one observation at a time. You have a list corresponding to each of those observations, and they're getting stacked into that data frame by row. Okay, so you can pass in a list of lists, and that will turn you into a data frame as well, and you just pass in the column names. So that's one way to do it as well. We can do it from a dictionary. This is quite common. So this looks a lot like the JSON file format. That's why this is so important to understand. We'll see this in the EDA lecture. We're going to be importing data from the JSON file format, which is often spit out by something called an API, an application programming interface. Okay, what does this JSON file format kind of look like? So again, we're constructing a data frame by passing in something. In this case, we're passing in a dictionary where the keys of that dictionary are the column names, and the values of that dictionary are the elements of each column. So notice now, instead of passing in sort of individual rows, we're passing in each of the columns as part of a dictionary. Okay, you can also use a dictionary if you want to pass in rows. Notice in this case, though, we're duplicating the column names more than once each time. I would say this format is a lot more common than the one on the bottom right. But again, why am I teaching you this? You want to be able to recognize this format. This is going to come out in JSON. JSON can be converted to a data frame very often with enough massaging. And then finally, you can construct a data frame from an actual series. So we can construct two series here, series A and series B, using exactly the same techniques we saw before. And this looks very similar to the previous slide. We're giving the first column a name and passing in a particular series, the second column a name, passing in that second series, and that's building us a data frame. Okay, I'd say the most common, at least in Data 100, are going to be pandas.readcsv, and then that sort of JSON file format way of constructing a data frame. Notice this is what I mentioned before. If we want to make a one-column data frame, we can literally just pass in a series to that pd.dataframe. Notice SA is a series. If we pass it into pd.dataframe, we get back a one-column data frame. We can go back, excuse me, we can keep going forward here. We can also use the method to_frame to convert a series into a data frame. ToFrame is quite a useful function as well. Okay, again, you don't have to memorize all these, just know that they're out there. Okay, the index. We've talked about indices a little bit in context of series. So indices don't have to be numeric. They can also have a particular name. So let me show you. So let's say I read in that elections data frame that I had been working with before, but I actually specify now that I want to use the candidate column as the index. Before, I didn't specify an index, and so I got the default index that went from 0 to the number of rows -1. But now I'm actually giving it a column to use as the index, right, as IDs for the rows here. So notice if I read in the data frame this way, I don't have the 0 through 187 that we had before. Instead, I now have a column. One of my columns became the actual index. Now, you might notice something kind of weird about that index if each of those are supposed to sort of represent row IDs. Something is kind of funky here. Notice the values aren't unique, right? Andrew Jackson appears more than once. So an index doesn't have to be unique. It's generally good to have unique indices, but there can be cases where you're not going to have unique indices and you might want to do some grouping of rows. Okay, but in general, they will be unique. Just know they don't have to be unique. Okay, so again, this is the same thing we were just saying. Notice if I just pull in this particular data frame and I don't give it an index, I get a default index back. If I specify one of the columns as an index, notice I don't have to have unique values in the index. Of course, you could have unique values in that column and it could just turn out that all of the values in that column are unique. Okay, you're not guaranteed to always have a non-unique index when you pull in a column like this. Just know it can happen. Okay, there's a little link at the very bottom if you're curious about when these non-unique indices are actually useful. I'll let you check that out offline. Okay, two useful functions, and then I'm going to introduce you to the reference sheet on this slide. So let's say I want to take my original elections data frame. The original data frame is indexed 0 to the number of rows -1. Each one of those indices is unique. If I use this setIndex function, the setIndex method, I can change my index to one of the existing columns. So notice I'm going to be moving from right to left here. Same data frame, same order. That original index is now gone, the numeric index, and I've now changed the index to the candidate. This is the first thing we've seen so far that's going to be on the Data 100 reference sheet, which you can go check out. So anytime you see this little panda holding up a piece of paper, okay, it means that it's on the Data 100 reference sheet, which you can use on exams. And also, I've heard people like to use even outside of Data 100. It could be nice to read through that reference. Linked right here, also linked on the website. This semester's specific reference sheet is not up yet. That'll come up right before the exam. This is an older reference sheet. They don't change much semester to semester. Let's say you imported something or you changed an index and you want to go back to the original index. Instead of setting the index, you can reset the index. Very commonly used. I use reset index all the time. Again, this is also on the reference sheet. Things that are on the reference sheet tend to be used on the exam. We won't ever test you on like really minute syntax on the exam without including something about that on the reference sheet. Again, we're not here to test you on really specific syntax, memorizing that on the fly. Okay, most of the time it's going to be on the reference sheet. All right, lots of things about data frames. A couple more before we go into a demo, and then another Slido. So to extract row labels, again, we can just pull it out with .index, kind of like what we had with the series. If we want the index, we can do .index. Okay, if we want the columns of a data frame, we can get the names with .columns. And if we want the shape or the dimensions of the data frame, we can use .shape. We have 187 rows, and we have 6 columns. Okay, notice first and third thing are both on the reference sheet. Second thing is not on the reference sheet. Doesn't mean it's not useful. It's just not often used on exams. We usually give you all the columns of any of the data frames you're working with. Okay, all right. I think that takes us to a demo. So let's go now over to the demo, which is going to go through everything we just did, just in code. So now let's switch over to the demo. Okay, let's go back up. We are now here. So I'm just going to show you everything we just did in code. So everything we just talked about, we're doing once again. So we can read in a data frame with pd.readcsv. pd.readcsv. Notice when I pressed Shift-Enter just now, I got sort of pushed down. Okay, if you want to stay in place, you can do Command-Enter, at least on a Mac, corresponding thing on a PC. So notice I'm just reading in this elections.csv file. We'll see next time how to actually go play around with raw CSV files. I think we can go to open with CSV viewer. Let's see, we want to do open with editor. So in a couple lectures, we'll learn how to work with actually raw CSV values and sort of break these things down. But for now, Pandas is going to abstract away a lot of that nastiness for us. Okay, so we can read it in with the CSV. Okay, we can change the index, pass in a particular column if we want to change the index. Okay, different ways to create a data frame. We saw this just now. Pass in a list, pass in a column name, pass in a series of rows here. Each sublist represents a particular row. Create it from a dictionary. This is the same thing we just saw in the slides, where we're passing in a dictionary that can either give us our data frame by columns or our data frame by rows. And then creating from a series, I'm going to skip ahead here, not super important, and then resetting the index. Let's go ahead and head back to the slides just because we saw all this. Let's actually just go practice this. I think that'll be the most useful thing. Why don't we try this out? Let's do a Slido. Which of those lines of code creates that data frame? And again, you can raise your hand. I can come around and help if you got questions, and feel free to ask on Slido as well. And I should have said this sooner, but feel free to talk with your neighbors during Slidos. You don't have to work on these alone. You're welcome to. We have 3 more today, so just keep that in mind. Feel free to chat with people. All right, we're getting close to that 93. I'll leave the Slido active, but let's move over to the Slido in the demo. So I'm going to scroll to the very bottom here. Okay, let's take a look here. So what we want is this output. We want a data frame that has default index, 0 and 1. It has 2 columns, group and score. And we can see in the group column, we have A and B. In the score column, we have 84 and 79. So let's see what's going on here. So in the first case, we're passing into pd.dataframe 2 lists. We're passing in 2 lists. We saw before that when we pass in sublists this way, we pass them in by row, not by column. So notice when we run this, we get something that's sort of similar to the right answer, but instead of getting A and B in the first column, we're getting A and B in the first row. It's expecting each of those as a row observation. Okay, so very, very close here. The second one, I believe, is going to get this right. Notice that the first observation is A and 84. That's exactly what's going on here. The second observation is B and 79. We're passing those in as sublists. This should work out just fine. And it does. And it does. So that one works. DF2 is correct. Let's keep going here. Okay, now we're using the dictionary method. So something funky is going on here. We're saying A corresponds to 84 and B corresponds to 79. The letters here and the numbers here are sort of indistinguishable in the sense that they're all sort of values in the data frame. There's really no reason why these particular values in the data frame would be keys and these particular values in the data frame would be values. It doesn't quite make sense. Okay, so we get something kind of funky here that doesn't quite work. Okay, normally when we pass in a dictionary this way, these are specifying the column names, but then we seem to be specifying the column names again. Doesn't work out. Okay, DF3 is not going to work. Okay, next one. What about this one? Pandas.dataframe, we're passing in a dictionary, so we can either pass in rows or we can pass in columns this way. So we have the first key, column name, and all of its values, A and B. Sounds good. Second column name, score, and all of its values, 84 and 79. Sounds good. Okay, this is good. So again, this is a lot like the JSON file format. I know I keep saying the word JSON. For those who haven't heard that before, it kind of sounds like JSON. Okay, just know that's coming in a future lecture. Very, very common file format. Looks a lot like this. And then DF5, let's see what's going on here. We got some duplication going on. So we have a dictionary. We have a list of dictionaries being passed in here. Okay, each of these sub-dictionaries is giving me particular column along with the corresponding value, particular column along with the corresponding value. Each of these sub-dictionaries represents a row, and we have to tell pandas which value corresponds with each column. And so this is going to work as well, even though it's a little bit messier. We're passing in, instead of sublists, we're passing in sub-dictionaries, okay, where each of the column names are specified. Okay, and then finally, this looks like a different question, so we don't have to worry about that one. Okay, I think that belongs on the next piece. Okay, we'll go back to the slides. Great, nice. We're doing great. Good work, everybody. Okay, DataFrame API. I mentioned the word API before. API for the DataFrame class is enormous. Programming interface, it's a way to interface with a particular website or database, lots of different things you can do with APIs. Okay, the full documentation for pandas you can find at that link. Again, if there's something you want to do with a table, somebody probably already wrote a pandas function for doing exactly that. No need to memorize those things. You can look them up on the fly. And now that we have large language models to help us, it can help you find that very specific function you're looking for rather than having to write some custom function that you spend days on. Okay, so just keep that in mind. We're only showing you a small sliver of everything you can do in pandas. Okay, I know we hit about the interlude mark, so yeah, why don't we go ahead and take a little 2-3 minute stretch break here. If you got questions, I can come around, and otherwise see you in about 2 or 3 minutes. Did anybody not get Smarties who wanted Smarties? Where did the bag end up? Did we finish the bag? Bag's finished? No, it's probably sitting somewhere. Okay, yeah, you want to keep passing them around? Maybe people want a little bit more. Go ahead, you can take as many as you like. All right, let's keep going here. So it's funny, in Data 100, there's a little bit of a love-hate relationship among students when it comes to demos. So about a third of the class is like, I really love demos, we need to do more demos. About a third of the class is like, fewer demos, I can do these at home, and then a third don't mention them. So I'll try to do demos when I think it's really essential for us to work through the code. Okay, but just know you can also do them offline. They're written in a way where you can sort of work through them independently. Okay, so just keep that in mind. Keep that in mind. Okie doke, let's keep going. All right, it's time for some data extraction with loc, iloc, and not missing information. We're actually gonna go extract data using brackets. Okay, so this is the last section of the slides, but it should take us to the very end of today. And if we finish early, that's amazing. Pandas is usually super, super rushed, so we're doing great on time if that's the case. Okay, extracting data. How do we extract data? So there's lots of different ways to extract data from a data frame. Again, many ways to do the same thing in pandas. That's a big theme of this lecture. So several different things we might want to do. Let's say you have a data frame you just imported, and you want to take a peek at the first couple rows of that data frame. Or you want to take a peek at the last couple rows of that data frame. That's something you might want to do. Just extract those couple rows. Super useful operation. Let's say you want to grab particular data that has some label. Okay, we have some identification for some data that you want. We might want to pull that data out of the data frame or grab data that falls at a certain position. So we'll talk about each of these. So the simplest scenario and something you're going to be using a lot in Data 100 and beyond, this is something I do constantly when I do data science work, is just looking at the first n rows of a data frame. And to do that, we use the words head and tail, the head of a data frame and the tail of a data frame. The head is the top, the tail is the bottom of a data frame. Okay, so if I have the elections data frame and I write elections.head and I put a 5 in there, that says return the first 5 rows. Now just keep in mind, if I don't put an argument inside of head, I will still get 5 rows back. 5 is the default. But if you want 10, you want 20, you can dump that number into head. I think very often people never put a number in head and they just write that in their code. So you'll sometimes see that. Just .head without any arguments. And you might imagine .tail, which is used a lot less than .head. I very rarely use .tail. Works exactly the same way. Just gets you the bottom 5 rows of a data frame. But .head is used constantly. That'll be pretty much in every single one of the notebooks you ever work with when it comes to working with a table. Okay, so that's just a simple thing, grabbing the first 5 rows. Now, one thing I like to mention about .head is that this can be sort of a dangerous way to inspect a data frame. Any ideas why this might be a dangerous way to get a sense of what's inside of a data frame? Any ideas here? Why might just looking at the first, let's say, 5 rows of a 10,000 row data frame be something sort of misleading? Yeah, go ahead. And this is like a perfect thing, and I'll try to mention this once again, and I think it's forgotten very often because people will write .head all the time. I really try to stray from actually using .head in real work, and instead I use something called .sample, which we'll see in a future lecture, because those first 5 rows might be totally unrepresentative of the rest of the data set. For example, I work with a lot of data from police stops, and sometimes date gets recorded incorrectly. And I get dates in my data frame from like the 50s and 60s and 80s that really shouldn't be from the 50s and 60s and 80s. And then the data frame is sorted by date. And now the beginning of my data frame all has either like NAs or it has a bunch of data that was recorded really poorly. And I'm getting sort of like a false sense of what's going on in this data frame. So I just want you to keep that in mind. I think it's easy to forget that when you learn .head. You're like, oh, great, I can inspect a data frame. And that is very useful. But just remember, there's no guarantees that it's representative. Okay, just keep that in mind. Okay, a more complex task. Let's do something a little more complex than just arbitrarily grabbing a couple rows here. So again, this is on the reference sheet here, but we can use something called df.loc. Loc stands for location. We can grab data that falls at a particular row label and a particular column label, one or more labels. Okay, so how do we do this? So labels of a data frame are at the top and the left side. Column names and the indices here. So these are the row labels, 0 through 186. Whatever your index is, are your row labels. Your column labels are all of your column names at the very top. And so .lock, we're going to pass in particular row labels and particular column labels to grab those pieces out of a data frame. Okay, so let's actually try this out. So you can pass in lots of different things to .lock. Again, many different ways to do the same thing in pandas. So you can pass in lists. .lock typically gets passed in 2 arguments. We'll see in a bit, if you only pass 1 argument to .lock, it sort of assumes the second argument is a colon. We'll see this in a sec. But whenever you think of .lock, and we'll see in a bit .iloc, you want to think, I need to provide 2 arguments. I need to provide something that tells me about which rows to look at and something that tells me about which columns to look at. Okay, so in this case, I'm going into the elections data frame. Go grab the location of that data frame that corresponds to the rows 87, 25, and 179. Notice they don't have to be in order. You can grab in whatever order you like and grab from the columns listed in that list. Nothing crazy. Okay, that's one way to use .lock. Just provide the explicit row labels and provide the explicit column labels. You can also use something called a slice. This is exactly what we just said. You can also grab a slice. What is a slice? A slice is when you use this colon to represent, grab all of the columns starting from popular vote, extending all the way to the % column, kind of a funky named column. So in this case, we're grabbing those same rows, 87, 25, and 179, but now we're grabbing the columns from popular vote all the way to %. Anything dangerous about using a slice? Anything dangerous about using a slice this way when you're working with a data frame? Maybe thinking about somebody else reading your code. What could maybe be not ideal in the real world about using a slice? Any ideas? Yes. It's hard to read, right? What's in between popular vote and %? If I'm reading your code, I don't know what's in between popular vote and %. Maybe you do in an exploratory data analysis, that's fine. But in a real world setting, you want to write code that's readable by others. And so while slicing works, and it's still like a very useful thing, I'll try to point out little tips and tricks and contexts like this so you can think about how you actually run an analysis out there in the real world. Just because you can do something some way doesn't mean you necessarily should do it that way. Okay, and then we can also use a single value to extract elements. So quick interlude here. This colon I mentioned, let's say we want to pull all of the rows corresponding to a particular set of columns. So notice what's going on here. I'm saying grab all rows, that means everything you've got, all rows for those 3 columns. I'm essentially just selecting those 3 columns. Okay, so if I do that, the output looks something like this. Notice I get year, candidate, and result here. So I get those same 3 columns I asked for, and I have everything in the data frame. Okay, keep in mind if you see these ellipses in your pandas printout, it just means there's a lot more rows hanging out inside of that pandas data frame, and it's not going to print all of them out for you, unless you tell it to. Okay, same idea for columns. So I can pass in a set of row labels and then say grab the entire data frame at those row labels. Super useful operation to use this colon. Notice, if you can actually go do this if you want in the demo. If you go just run elections.lock without that colon, you'll get exactly the same result. Just note, if you don't pass a second argument to .lock, it assumes that second argument is just a colon. So whatever you pass in, it's going to grab those rows and then just assume you want all of the columns. Okay, just keep that in mind. Okay, and then like I said, you can also just pass in a single value to .lock. So instead of passing in a list, notice I pass in a list for the rows, I just want one of those columns. Any guesses what's going to happen if I just try to pull out one of those columns? Any guesses what's going to happen? Will I necessarily get a data frame back? If I pull out one column, what is one column of a data frame? That is a series. So if you pull out one of these columns, notice it doesn't get printed out as nicely because we're just getting back a series. Okay, we're just getting back a series. Same idea here. We can now grab a single value from our data frame, actually go pinpoint a single value, grab the element at the 0th roll in the candidate column. Okay, another way to do things. All right. I think we have a demo slide, which I'm going to skip in favor of a Slido. Slido, let's try this out. Raise your hand if you have questions too. I can come around. I'm also getting a lot of great questions throughout this whole lecture about different possibilities. Is this possible with pandas? Hopefully, fortunately, I've been able to answer them so far. But the best thing to do is to actually go to the demo and try that out and see what happens, and actually see what happens. Again, I haven't spent the time to memorize the entire pandas documentation because it's not a useful use of my time, right? So just keep that in mind. Go try it out, see what happens. If we get an error, we can talk through it together. Getting close to our number here. I'll leave the Slido live so you can keep playing with it if you're still working. But let's go ahead and play with some of these in the demo. So we're going to scroll all the way to the bottom, which I think we're already scrolled to. Oh, great, we're already there. Okay. All right. Questions 3, 4, and 5. They're all going to share the same data frame. This way you can sort of see the similarities between .loc, .iloc, and what's called context-dependent extraction. So we're going to create our data frame called weird. This is that data frame we were just working with, and we're going to print it out each time. You'll see why I'm doing that in just a sec. So weird.loc11 is saying grab the data with a row label of 1, okay, and we're trying to get bluefish, and then try to grab with a column label of 1. I don't see a column labeled 1. I don't see a column labeled 1, even though this is technically the 0th column in the first column, not going to work with loc. Will work with iloc. We'll see that in a second. Okay, so we need an actual label. .loc, location, it's a label-based extraction. Label-based extraction. All right, let's try another one. So we have weird. Now I want to grab the element with a row label of 1 and a column label of B. That sounds like bluefish to me. That works. We're in business. Let's try the other ones. Okay, weird.loc, passing in a list. So I said before that loc and iloc, in data 100, you want to think of them as getting 2 arguments. What are the row labels and what are the column labels? In this case, we've passed in a list, which is 1 object. And so under the hood, .loc is inserting a colon there because it doesn't know what your second argument is. And so this is actually saying, grab the data at a row index of 1 2 times and grab all of the columns. Grab the row index 1 2 times with all of the columns, and it just stacks them on top of each other. That's not very useful. That's not very useful, but that's why you're getting this funky output. Okay, another one. We're going to get sort of a similar problem here. Same idea. We don't have a second argument. .loc is implicitly going to throw in a colon. It's going to implicitly throw in a colon, and it is going to go look for the row index 1, which exists, and then the row index B, which doesn't exist. So we get an error. Okay, that's .loc. That's .loc. All right, let's now go ahead, head back to the slides, and let's do, great. Let's do some more with iloc and context-based extraction. Okay, different scenario. Different scenario, less common scenario. .iloc is not used all that frequently. You should know it exists and it can be useful in specific circumstances. So the I in iloc stands for integer. .iloc is saying grab something based on its integer location. So instead of passing in a row label and a column label, we're passing in a integer for the row regardless of its label and an integer for the column regardless of its label. Okay, so Python convention, first position has integer index 0. In R, it's 1. Okay, we have a data frame. Our row integers go from 0 to however many rows there are minus 1. Now keep in mind, in this case, the index was the same as the row integers. We saw before a case where we made the candidate column our index. The row integers on the far left are the same. For .iloc, you are still using integers. The column integers work exactly the same way. The first column is 0, second column is 1, and so on. So .iloc, you're passing in a row integer, you're passing in a column integer, and you're getting the corresponding data back. So very similar to .loc in that way, we're just passing in integers. So let's see it in action. So the two arguments, again, to .iloc. What are the two arguments to .iloc? We can pass in a list. We can pass in a slice. Slices are exclusive in iloc. Now that we're working in integer land, things work a lot like the range function in Python, where it's exclusive on the right-hand side. Would we test on a Data 100 exam, is iloc exclusive or inclusive on the right-hand side? Probably not. Right? That's not a very useful thing for us to test. We're generally testing like important and big ideas. Okay? Not sort of minute syntax things like that. And we usually give credit for small syntax errors too. Just keep that in mind. Focus on the big ideas in this class. Okay, so elections.iloc, if we pass in two lists, 1, 2, 3, 0, 1, 2, we want the rows at positions 1, 2, and 3. That's the second row, the third row, and the fourth row. Right? The first row goes with 0, and then we're grabbing the first, second, and third columns. Easy peasy, nothing crazy here. We can pass in a slice. Notice now our slices have to be numeric. Okay, our slices have to be numeric. Just keep in mind, these slices are exclusive in iloc. Just the behavior sort of following this idea where sort of range would exclude b and would just go up to b minus 1. Okay, so we're grabbing 1, 2, and 3 again, and we're grabbing 0, 1, and 2. We are not including column label 3. Okay, or we can pass in just a single value. Okay, this is just like before. Again, we can use the colon to grab all of the rows if we want. We can use the colon to grab all of the rows and then just a subset of columns. So this colon can be very useful as shorthand for just grab everything. Grab everything. Either grab all the rows or grab all the columns. Okay. All right, again, we can pass in a single value. In this case, we're getting rows 1, 2, and 3, and just the second column, right? Column that's indexed with a 1. If you just pull out one column, you're going to get a series back, because a column is just a series under the hood. If we want a single value, we can just pass in a single row integer and a single column integer. That'll just give us a single value. So that's .iloc. Hopefully not too concerning after seeing .loc. We're now just using integers. But let's actually go try it out. Let's give this a go. Another Slido here. And again, feel free to raise your hand. I can come around and help. We can talk through error messages, all kinds of fun stuff. To your future self watching the recording or to anyone on Zoom, the beginning of the recording was a little bit blurry and we were trying to figure out why, and we thought it was a problem with the camera, but my camera was on blurred background, so we're fixed now. We've hopefully ironed out all of the bugs from lecture 1 and 2. Okay, why don't we go ahead, move over to the demo. I'll leave this open so people can still answer if you haven't answered yet, but let's go give this a go. So let's print out that weird data frame again. Okay, we're trying to grab bluefish. Again, we're just trying to grab that single bluefish value. So weird.iloc is saying grab the first row integer. Good, corresponds to this first index, that's nice. And then also the first column integer. This is the 0th column, this is the first column. That sounds like it's gonna work. Didn't work with .lock, works now, because we have integer positions. Okay, another one. Here's like another gimme where we're passing in now a list. If we pass in a single argument, remember .iloc and .lock assume the second argument is a colon and are essentially just saying grab everything. So this is very similar to the bug we had before where we're grabbing the first row and we're doing it twice, or the row integer 1 row. So it's the second row in this case, and we're doing it twice. So that's going to give us that weird output of just giving this second row 2 times. Okay, what about 2-2? 2-2 in this case, again, Python is 0 indexed, so there isn't a second row, there isn't a second column. We get an error, right? We only have row integers 0 and 1 and column integers 0 and 1 as well. So that's not going to work. And then finally, what happens now if we try to pass in something that's not an integer to iloc? So we're grabbing the row integer 1, great. We're trying to grab this column B, but in iloc, it won't recognize. So that's exactly the correct code with .lock, but it doesn't work with .iloc. We can only use integers with .iloc. Okay? We've got .lock down, we've got .iloc down, and we're doing great on time. Let's go ahead and head back to the slides now. Looks like we got lots of participation here. Looks like we're in business. Okay, great. Great, great, great. All right. So .lock versus .iloc, some sort of just tips and tricks to understand here. So keep in mind, .lock stands for location. The .l performs label-based extraction. This is something like a big idea you should understand for Data 100, remembering that .lock goes with labels. Big idea, right? Not a little syntactical thing. .iloc, you can remember the I stands for integer-based extraction. You can only pass in integers. Okay, when choosing between the two, like I sort of hinted at before, .lock tends to be better. Why is that? It's safer. If your code gets shuffled in some database and changes order, the row integers still correspond to whatever order the data is currently in. And so that's not very safe if your data gets shuffled. And then it's also more readable. It's also more readable. .iloc is a lot like kind of matrix notation, where you're using numbers to index into a data frame. For humans, when we're reading code, it's easier to read labels. But .iloc is still useful in some specific circumstances. So for example, you have some data frame that's sorted by box office earnings, and you want to grab the median, you could use .iloc. Sometimes when you're working on a data science project and data is sort of streaming in by column, you're going to get like column of data, column of data, column of data, column of data, and it's going to keep going. And those columns aren't going to have names by default. They might just be given integers. And so you might use .iloc to refer to, oh, what is my 37th simulation, right? My 37th simulation's worth of data I can grab with .iloc. Okay, so there are cases where .iloc is still very useful, but for the kind of data science we're doing in Data 100, .lock is going to be even more useful. But even more useful than .lock is this context-based extraction. So this was on the slide earlier. If people don't understand the reference, back in the 80s, there was a commercial where the Kool-Aid guy like came through the door. But then recently, there's been this phenomenon where like teenagers are running through fences and doing the Kool-Aid guy thing. I thought this was kind of funny. I just heard about this not long ago. Don't go do that. Don't go do that. But anyway, if you're wondering, now we have this new thing coming right through the door here. Okay, you can watch the full video offline if you'd like. Didn't know you're going to learn about other stuff in Data 100. Okay, so .lock selects by label, .iloc selects by integer, but this context-based extraction only takes one argument. So in .lock and .iloc, we're being very specific. What rows do you want? What columns do you want? With this context-based extraction, it depends, which kind of sounds scary, but just keep in mind this is what people are using way more than .loc. Okay, .loc is still useful in specific circumstances, but context-based extraction is what people are using the most often by far. So you might give a slice of row numbers. If you're passing numbers to brackets alone, Pandas is going to assume you're asking about rows. If you pass in a set of strings, it's going to assume you're asking about columns. You can also pass in a single column label. So let me show you this in action. Okay, let's see this in action. So we can pass in a slice of integers. So if I pass just a slice of integers right into brackets, so notice in this case, we are not using .loc, we're not using .iloc, we are just throwing brackets next to the name of our data frame. If I'm passing in integers, it's assuming you want rows with ID 3 through 7. Okay, right, 3 through 7. In this case, notice, again, whenever we're working with numbers, we're exclusive. So it's going to exclude number 7. Okay, it's going to exclude that number 7 because we're working with integers. Notice in this case, we get 3 through 6. We get 3 through 6 here. Okay, whenever we're working with sort of strings, inclusive. A list of column labels. So we can actually go pass in column labels. I'm passing in a list in this case. Notice the double brackets. I have to pass in a list to the context-based extraction brackets. Okay, common typo. In this case, I'm just pulling those 3 columns. I'm just pulling out those 3 columns. Nothing crazy here, but it just knows, this context-based extraction, that you're referring to columns. And then finally, I might just pass in a single column label. Any guesses what we're going to get back if we just pass in a single column label? What object are we going to get? Series, right? We're going to get a series back, not a data frame back. Notice in the bottom right, it says over here, if you do want a 1-column data frame, just pass it in as a 1-element list. Just pass in candidate as a 1-element list. So when you pass in a list to this context-based extraction, you're going to get back a data frame. When you pass in just a single element, you're going to get back a series. Okay, I like the GIF, but we're not going to do the demo slides here. More extraction GIFs. Let's go ahead and do a Slido here. Let's go ahead and do a Slido. So context-dependent extraction, which of those will correctly return blue fish? Let me pull that off so you can see. Give this a go. Okay, it looks like we're getting close to the settle point. I'm going to leave this Slido open and move over to the demo so you can submit some more answers. But let's try this out now with context-based extraction. So we have our weird data frame, and now we're trying lots of different things here without using .loc and without using .iloc. So the first thing we're going to do here is weird with a 1. Weird with a 1. So let me just go do this separately here. if I write weird with just a 1, based on context-based extraction, this is going to say, go grab, we don't know. Okay, we can't just grab a single value. It's not going to work. We get a key error, right? Let's say we wanted weird, something like that. That works. We can pass in a set of row integers, but if we just pass in a single one, it's not going to work. Context-based extraction doesn't know what to do with that. Okay, it doesn't know whether 1 represents a row or whether there's maybe a column labeled 1. It's not working. Okay, it doesn't work out. Let's keep going. So weird 1b is just going to give us an error. Not going to work out. Cool? Okay, what about weird b1? Other way around. So we're now saying, okay, weird b, this is something you're going to write a lot in your code, data frame followed by a column in this, as a string here. That's going to pull out the b column. That's going to pull out the b column. Great. So we now have redfish, bluefish. And then if we go look in that series for the 1 index, that should pull out bluefish like we want. Okay? So that works. That's exactly right. Weird b1 works with context-based extraction. Okay, so weird, again, what's going to happen here? If I try to pass in 2 arguments into context-based extraction, I get a problem. If I use .lock, I don't have a problem. .lock is expecting 2 arguments, but context-based extraction, just those brackets alone, that's going to give me an error. Okay, that's going to give me an error. So that's not going to work. Context-based extraction, single argument, single argument. Okay, last one here. Let's go to the weird data frame. We're still passing in 1 argument here. We're passing in 1 argument. We're passing in a list. We're passing in a list. What is it going to try to do? Doesn't really know. Are we trying to grab rows in this case? We want integer labels. One of them is an integer label. We have the 1, but b is a string, is not an integer label. So that's not going to work. Okay? So now we are experts at extraction. Great. Good one to review. Okay. All righty. So why should you use context-based extraction? Ultimately, it's just a lot shorter and more concise. You don't have to type as much. And I think this example sort of knocks it out of the park. If I want to extract the candidate column, I shouldn't have to do anything except specify that I want the candidate column. I shouldn't have to include all this extra information. I shouldn't have to say, I want all rows and the candidate column and type .lock. Okay, so often if you're getting errors with context-based extraction, that's when you'll turn to .lock to be really specific about what you're looking for. Okay, but typically you're going to be using context-based extraction. Okay, all right, we've done something miraculous. We've finished the first Pandas lecture early. I'll go ahead and end the recording. If anybody wants to sort of start extended office hours down here, I can do that. I can also walk through the demo if you want. But yeah, feel free, head out if you're good. If you want to talk a little bit more, come on up to the front and we can keep going. But thanks everybody. See you tomorrow.